Hi. Good afternoon, everyone, whoever have joined us on this Saturday afternoon. Very welcome to you guys to this masterclass on Apache Spark. And we will be, we are just wait for maybe like a minute or two before we jump onto the content with Abhinav here. And so let me just start off you guys with giving a brief introduction to AntWak platform. AntWak is a experiential learning platform, and throughout this year and a half now, we are trying to build inclusive educational ecosystem where professionals, like no matter if you are on a very early stage of your career or someone who have an experience of 10 or 15 years like that, they are able to continue their learning journey in best possible way possible. We bring a lot of experience from industry folks who are currently working in these niche domains, and try to they are sharing their knowledge of the other folks in the industry, and creating an inclusive and very collaborative ecosystem of sharing knowledge and gaining expertise from that. So that's the thesis on which we work on. Currently, we also have dedicated master classes and like these free master classes plus some dedicated boot camps, which are in the data engineering, cybersecurity, and digital marketing domain. We are currently running. So I would encourage you guys to do check those out also on antwak.com. And without further ado, I dive into the our today's class. So, Abhinav, can you just move the slide?
Yeah, sure.
Yeah. So just start off with, I would like to thanks Abhinav for making this possible, agreeing for doing this collaboration with us. Abhinav is a senior data engineer with NQO, and he have some 4+ years of experience in designing and development of the complex enterprise applications in data engineering and analytics domain. Of course, he comes with a really good expertise onto the very popular tools and technologies of data engineering and analytics, like Apache Spark, Elasticsearch, Kafka is there. Overall, the Hadoop ecosystem and NoSQL and SQL databases like Postgres, MySQL, and Cassandra, and MongoDB, etc., are some of his tools that he day in and day out work with. Of course, he have like previously worked with Paytm, Airtel Payments Bank, and in the data engineering and all these domains. So I really hope you guys will find his experience to be valuable here. Meanwhile, I would request you guys to also put on some, like as we will be going through the content, if you have some questions, please feel free to put them in chat. We will take up those maybe in the end of the session, if it's relevant to the topic, we can maybe take in the middle also. So feel free to drop those questions, and now I think we can start. So over to you, Abhinav.
Yeah, thanks, Digvijay. Yeah. Hi, guys. So yeah, that was a brief introduction about me. I've worked in data engineering ecosystem for quite a long time, and so I've just finished a project with VMware, and we'll be going to do another project with Atlassian now, in the same data engineering domain. I have worked on Spark SQL, Spark streaming, also preparing data pipelines for machine learning data models. So that's what my expertise in. And yeah, Spark has been a great help, and it has been the leading tool in the industry to basically solve all those problems. Yeah. So these are our, like, today's basically sessions that you'll be getting brief about, like how does a data engineering, like data processing pipeline looks like, and where does Spark comes in, and how Sparks, what is Spark and how Sparks help solving the problem of data processing, and then the features and benefits of Spark and the overall architecture of how like a brief architecture of Spark looks like. And then of course its use cases in real time and how companies are basically solving it. So I'll be very encouraging if like especially in the time of architecture or use cases, that is the time you should really be uh, messaging about like what are the topics you are not understanding, so that like and I can take up those topics at that time only. And of course then we have Q&A in which you can ask about what's the career path and what are the best tools and technologies you should look on, and whatever comes to your mind, right? Yeah, so poll Digvijay. uh,
Yeah, so we are just launching a poll. Can we have it? Yeah. So we're just trying to understand like what's the sort of audience we have for today. So guys, please fill that. It will help us to really take this session forward into what direction.
and they can fill the poll parallelly, or like do I have to
Yeah,
wait
yeah,
for some time?
yeah. I think most of the people are done. So 70%
Oh,
of
cool.
them have filled the poll. We can
Cool, cool.
yeah, we can see
Yeah,
the results, right?
yeah, I can see the results. Yeah.
Yeah,
Great, guys, great. So basically, when you talk about data engineering, these are the things you should, uh, you know, uh, have look upon. Like, so whether you will be working on a cloud, like whether it is a GCP or it's a company has its own data centers, or it's AWS or Azure, whether the kind of data you are working with, is it structured, semi-structured, unstructured. Difference between them will be structured will be the basic rows and columns, like the data in Excel or a CSV or like RDBMS, right? The structured data is that basically which can be defined into any kind of columns and have values. Semi-structure will be, of course, the data which in XMLs, JSONs, those kind of data you need to play with. And like if it's getting from an API, which is not probably the standardizations of file format. And unstructured data will be like, for example, you are taking POAs of your customers, like they are providing with you with their Aadhaar photocopies, or all the images, all the audio files. So those come in unstructured data. So you should really know what you are playing with while using a technology in data engineering. So because of this data, the platform changes and the approaches changes. And of course, the languages, I mean, these four are the basic languages which people use in data engineering ecosystem. Python being the most rated because it's like the most simple language. A beginner can get hands on it. It's very uh, easy to learn, and it can solve basically all the problems like data analysis, data mining, data cleaning, data visualizations. It can take care of all the rest. And also in this whole data engineering ecosystem, Python will be the language in which all the tools and technologies are worked on. Like, so you will get Spark, you will get any visualization tool in Python. So that's why it's more prevailing. And of course, if you talk about specifically about Spark, people use Scala because it's been developed in Java and Scala. So that's why people use Scala, especially for uh, Spark. And then Java, I mean, it sustains in each and every ecosystem. And Java has been like, it has been proven like the best language for probably like last 15 years, because it has been consistently delivering the big ecosystem solutions. And like right now also, you can also write code in Java for Data Spark. So uh, it's proven to be evolving with the timeline and the technologies. And R, yeah, not least, not the least, but like most data analysts use it for data analysis. I mean, it's very good for you when you uh, it can be used in with the Jupyter notebook. I mean, for most of the visualizations, and it has been a tool for the data analyst who basically perform after like the data is clean and data is mined. So after when you want to run models on them and after you want to like get insights from them, you usually use this language because it's very easy and they don't have to do much of the work because probably they'll know which algorithm to use. And then platform, yeah. So defining on your problem, right? You will be seeing which platform you use, right? So Spark, Hadoop, Airflow. So these are some vague terms, but overall it means that uh, probably you'll be using one or max two to max three uh, platforms in from these to solve your problem, like a solution towards Hive and a solution towards Spark is very different. I mean, they'll be solving a lot of different problems. Plus, they can solve a same problem when combined with each other. So you have to look at those, and you have to research about it. That what you should use for basically your problem, like the kind of problem you are serving for your company. And then like when the data is prepared, right, like you have gone through the platforms, you will be coming to visualizations because that's where the whole journey comes to an end, right? Like either the whole data you have processed, either it will be a dashboard, a report, or a generated another queue for another pipeline, right? One of those three things has to happen like when you have processed the data. And so Power BI and Tableau basically are the industry leaders in this. And if someone is interested in, please look at it. They both are great. And so specifically, Kibana is something else because it only comes with the ELK uh, ELK ecosystem, in which like Elasticsearch is basically the database, and Logstash you use for like data pipelining, and Kibana you use for data visualizations. So yeah, that is brief about visualization. There are a lot of another visualization tools as well, like Grafana you will see, which can also connect to a lot of data sources. Yeah, so you need to look upon that when you start with your like data engineering. Like at least you should choose one of each boxes which you can see, and try to make the best combination for yourself. Okay, uh, let me see. Okay. Yeah, so data operation lifecycle, right? Now we're gonna get deep into what happens, like why you process data, when do you process data, right? So data operation lifecycle starts with, of course, data, right? Either you have like you have huge, like so initially it will be you will be categorizing like whether your data is structured or unstructured, like whether you have a lot of images to work on or a lot of CSV or Parquet files or API data or database to work on. So that's where you'll distinguish, right? Okay, so this is my way of path of going because that kind of data I'll be processing, right? And of course, so there can be huge number of data sources, like there can be file systems like Parquet, Abro, CSV, Excel. There can be JSON files, there can be APIs, there can be it can be a relational database. You can do a web scraping and get data from all the websites which you want. So those are different types of data sources you will be working on depending on your problem. Yeah, and so data extraction, of course. So raw will be getting data from directly from data source, and like another unraw data will be whether it's already processed and already stored in a data lake or data hub and data warehouse. So these things, of course, are like very huge. I mean, you have to get down with it. That what is the data lake? What is the data warehouse? How does it raw and unprocessed data look like? I mean, we can talk about it, but probably if somebody has question, I'll answer it later. Yeah. Now we come to the main agenda, like which is R is data processing, right? And we are solving this by Spark, Apache Spark. So what is data processing? Like, for example, you have a huge number of CSV files or survey files, right? For example, you have Google Forms, which you have collected through various polls or various uh, Google Forms, right? So the data which you have collected, you'll be processing that. The the thing to look upon here is whether you are processing in batch or you are processing in real time, right? So, for example, like I work for a bank, right? So at that time, real time processing, what was the problem? In which basically what we have to do is we have to process the real time transactions which were happening, right? So that is kind of real time processing, which so PySpark. Also, I worked on PySpark, which is a Apache uh, Spark built in Python. So it sits in between the real-time transactions happening, and either you can validate the data, you can aggregate the data, you can transform it, you can enrich it, and then you can load it to whatever form you need it, right? So that is real-time processing. And so data cleansing, validation, aggregation, these are the like types. These will be the categories in which you'll be handling your data. Well, either you will be cleansing it, you'll be validating, or you'll be aggregating it, or all of the above. And then job scheduling. Yeah. So how do you schedule your jobs, right? Not talking specifically about Spark, data processing can be done in various ways. You can just write a Python script to uh, basically cleanse, validate, or aggregate your data. But how are you going to schedule it? So for scheduling, there are various, like you can use, if everybody has worked with Linux, so you can use your cron jobs, right, for scheduling, or you can use Airflow, which is like market reader right now, which will help you schedule your data processing code. And then comes data storage, right? So once you have processed the data, then you will be storing that data to somewhere. Like it can be a file system, which is SDFS, Hadoop, and it can be a normal CSV also. For example, if you want to provide that data to your sales team, so you'll be providing that in Excel sheets or CSV, or you will be saving that to a data warehouse, which will be a NoSQL database probably, or SDFS. And probably on top of that, there will be data dashboards, right? So that comes under data visualization. So how you are, uh, what kind of insights you are getting from that process data, and how you are providing it to other uh, product, right? So it can be a dashboard, it can be a report, it can be, yeah, one of those two things. Yeah. So that is the basic data operation life cycle, right? So you recognize what kind of data it is, you recognize uh, what kind of data it's coming from, the data source. So it can be file storage, API, web scraping, stuff like that. And then how you want to process it, you get down, like you want to process it in batch, like you take up probably 7 GB data in one time and then process it and then stores it, or you'll be processing it in real time, what all you'll be doing with it, and after processing, how you're going to store it, like either to NoSQL database, file storage, you name it. And then what sits on the top of it, like after you have collected all the data, what you're going to do with it. So you're going to provide insights through dashboards, you're going to provide insights through reports. Yeah, so that's the whole data operation cycle. In that domain, all data engineering people work basically. Anybody can have any amount of curiosity in any one of them. So they'll choose. It's up to individuals what they choose to work on. Yeah. So of course, like this session is about Apache Spark and the data processing part, right? So I'm gonna tell you about what is Spark, right? So it's a in-memory distributed processing system. Basically, okay, these terms comes in handy. Like what is in memory, right? So nothing in Spark is working with the file system or the room, what we call it, the hard disk. Either you have to do batch processing or you will be doing real time. That all data has to come into Apache Spark Mary. That's why it's fast. That's why it's the company industry leader. And what is distributed means? So you have probably worked, heard about this distributed processing, right? Distributed computing, distributed storage. So all these terms are very handy in these days. So distributed uh, storages will be like SDFS, where data is sitting on multiple servers, whereas in not being on just one, which used to happen in earlier like RDMMS or other file storages. Like if you store a CSV file, for example, it will sit on one server, whereas in if you have SDFS, it will be storing in different servers parallelly. And yes, it's a processor system. So that is Apache Spark. What you have to keep in mind is it is a in-memory data processing system, which is distributed. Distributed will get that later in the architecture, right? How does it distribute the data and how does it work with it? And like getting into any technology, you should know what, when, what, why, and how at least. When is, of course, it was launched in 2010 after like a successful period of Hadoop. So Hadoop was launched in probably 2002 and 2004, between that period. And for 6 long years, I mean, it was the world leader because it changed the game, because the file system was distributed and there was a data processing system with it, which was called MapReduce. But the problem was with MapReduce was it was very slow, because like all the intermediary data it was keeping in servers, which will be SDFS for that long. So there were a lot of input output operations. So that MapReduce job has to continuously go to server to get the data and then store the data for in between stages, right? That's what the problem Spark targeted. Okay, that's why the computation is taking more time, because it has to go to servers, like the storage, quite often. So that's how Spark gets into the picture. They designed it in, I think, Berkeley in 2010, and it was open source at that time, 2010 and 2011. So how it solves the problem that without going to the data storage multiple times, it keeps that data into its storage, into its memory, and then do steps on it. So yes, it is memory extensive, that you have to provide a lot of RAM, and depending on what kind of data you are, what kind of volume of data you are playing with, but it will be very fast. So all the validations, cleansing, processing, aggregating, transforming, enriching we talked about, it will be done all in memory. And only once it will be going, I think somebody has to be on mute. Yeah. So it will be going for only 2 to 3 times in that processing system. Like when first it will be reading that data, then the input output will happen, and then it will be storing that data. And if you have a bigger problem, you'll be caching or persisting that data in between also. So that's how Apache Spark works, and that's how Apache Spark solved that problem of map reduce jobs taking huge amount of time, like hours amount of time, to basically process a data, and which was batch. So earlier Spark, there was only batch, there was no real time. The batches can be like after 5 minutes or after 10 minutes or after 1 hour probably. But it was all batch. And when you get in memory data, you can solve various problems with it. And this best problem was getting the near real time aggregations and transformations for different kind of use cases. Yeah, so that was a little bit about Spark. Shoot the questions if you don't understand, but okay, let's go on with it and let's talk about Spark a little bit more. Yeah, as what I said that so what Hadoop had was a file system which was distributed, and top of that it was map reduced to get that data, right? So what Spark did it, so Spark saved the same problem that I'll get that data into in memory and then I can play around with it. Okay, cool. But once you once this batch processing was done, the problem arrived that okay, we are getting real-time data in huge volumes and we want to run like probably machine learning models on it. Yeah, maybe you want to recommend on the basis of how things are trending. Like right now, if you see Netflix, right? For example, you'll watch a movie on the basis of your clicks, it will recommend you another movie, which probably the cluster of you or a person like you have already watched, right? So that for that kind of problem, batch processing doesn't work, because if batch processing will be there, then you will get the recommendation by tomorrow or like by the next time you log in, or like how much time that MapReduce job has to run to provide the best recommended movie for you. And there comes Apache Spark with its technology of streaming. So you can get the real-time data on the basis of clicks, on the basis of like from NoSQL databases, APIs, and then stream that data through various messaging queues. Like Kafka is for mm, Kafka is used for mostly data centers, and in AWS, if you know about that ecosystem, SQS is the prevailing messaging queue, right? And then you can transform it on the real-time basis, and then either feed it to your machine learning model or recommendation engine, or you can store it in a database, right? And various other things like it provided the libraries like MLIB and GraphX for different problems as well. Like MLIB can be like if you want to do machine learning on real-time data, right? What you will do. So either you will feed that data to your recommendation system, or Spark also provide you the same libraries for clustering, regression, stuff like that. And you can do then and there and provide with the output of that data, like the inside of that data. And GraphX also, like Uber uses it to provide you like which is the Uber driver which is nearer to you, what should be the pricing. So those kind of problems are also being solved through Apache Spark in real time, and that too in huge volumes. So they have big clusters, like 100 of Spark clusters running at the same time and solving and probably feeding to each other for the end result, which will be like a recommendation engine or a pricing or probably something else. Yeah, I hope I'm clear with this because these are the things we'll be talking about. So one will be streaming and one will be batch processing. Batch processing stays the same as MapReduce, but in a different method. Whereas streaming is all new for Spark. Like it has never been done before. So I see a question which is, what is the difference between Hive and Spark, and which is better and what's why? Okay, I'll be telling this question later because I think you need to know what Hive is. So Hive is not a database which people think, and it just it's a various it's a different way of handling the data for different kind of use cases, right? Cool.
Here we have one more question here. Uh,
Yeah,
Hello. Is there any differences between APIs provided for Python, Java, Scala by Spark?
difference. Yeah, I mean, there is some different. Like if you probably develop your functionality in Scala, it will be much faster than if you deploy your services in Python. And that depends on how Python works and how Scala works and how Java works. So based on their own language processing speeds. Yes, the processing speed can vary, but the more or less the functionality remains the same. Like if you have a probably data frame in Python, you can have a similar data set in Scala and Java as well. Whereas in like Java, you will not get most of the things because Java is not used very most in data engineering, and it's an open source platform. So people like you and me, or like who have worked a lot on Apache Spark, will be making those high level functionality operators for those languages. So that's why Java does not have that kind of support from open source community. Whereas in Python, Scala, it's prevailing. I mean, you can choose any one of them. Depends on your feasibility, what you want to learn, or whatever you have mastered, and we can start deploying it. I hope that answer your question, right? Okay, yeah. So, what are the features of Spark, right? I mean, as I told you, first will be initially MapReduce only provided batch processing, whereas in Spark provided a lot of other libraries which will be streaming and machine learning and graph on a real-time basis. Okay, and ease of use as well. If like it can be run through a various lot of, so you can set up a standalone Spark cluster. You can set up with Mesos, which is a resource manager mostly used in industries, and Yarn, of course. Yarn is mostly used because it can serve Hadoop and Spark, both of them. So that's why. So people usually moved away from Hadoop, like not away, but they solve different problem. But the people who use Spark actually had this big data problem earlier, so they have already invested a lot in Hadoop. So it was very good for them that they don't have to put in another resource manager to run their Spark jobs. So that's why it has Yarn capability as well. So that's the benefit of using Apache Spark, that you don't have to uh, stick to one resource manager. It can be any one of them. And now Kubernetes also. Kubernetes also provide resource management for Spark jobs, which is huge because I think a brief about how Kubernetes works. It will provide you a container, in which container you will have some cores, some memory, some RAM as well. So that's how actually Spark also works. Then Kubernetes is a very good resource manager. So the people who have their own data centers are using Spark with Kubernetes right now. And yes, advanced analytics, we have talked about it. Multilingual, yeah. Yeah, whether you are good with Python, you have Java developers, or you want to learn Scala. I mean, still in any of the language uh, you can build up your Spark processing services, right? An open source
Yes.
community as well. If there is a problem and you think Spark is not able to, you know, probably provide with you the high level operator, you can go ahead, build on your own, and you can submit it to the open source community. And after, of course, solving your bugs, it will be published. And it's a huge deal if you get uh, con- become a contributor in Apache Spark. I mean, you'll get the calls next day about big uh, from the big market industry in this world. Yeah.
So, sir, hello, sir. Kubernetes is installing for how much RAM is a requirement in my system?
Okay. So your system is not a right method to like deploy any of the Spark services. I mean, you can play around with the sample data. For example, there are a lot of websites, right? Kaggle or something like that, right? You can get data from that and you can try to run on lower amount of volume of data. But for huge amount of data, my PC does not make any sense because we'll have 16, 40, 30, 32 max GB RAM in our laptop to run the games, right? But it's not enough when you talk about data is in GBs, right? So
Yes.
you need, and Apache is a extensive memory tool, so it needs that memory. That's the only thing it needs. So if you want to work with Spark, work in a cluster
Yes.
because it's distributed. The data will be distributed across the nodes which you have in your server, in your cluster. So then you will be able to see the real power of Spark, how smoothly it works and how it can handle the terabyte and petabytes of data. I can tell you a fact. The speed I mentioned, right? It's 10 to 100 times faster with than MapReduce, right? So how they managed it, like how this number came into it, that it's 100 times faster sometimes. So they take petabytes of data and they, like right now the processing tools which we have in market will be MapReduce and Spark, and probably Spark has taken over. So they try to sort that data through both of those processing tools uh, in petabytes of volume, and at that end of the result, how much time someone took, they got this number. So it's that fast. Apache Spark is that fast from MapReduce. So that's why it was, you know, a it was a difference maker altogether. Uh, and yeah, specific to that question, yes, you can set up Spark on your laptop, but it will not make sense because it will not be distributed. And so when not distributed, it just works like a script. I mean,
Okay.
the output will be just like a script, like how that then all the things will be like how Java handles the data, or how Python handles the data, or how Scala handles the data. Then it will be that if you are like doing it on a single standalone cluster. Got it?
Yes.
Cool.
Abhinav, this is
Yeah.
Purushottam. I have a question.
Yeah.
So there are a lot of ETL tools in the market, right? And I am
Got it.
assuming Apache Spark is one of those. So how is Apache Spark better than the other tools? Just a question. Like I have heard, like there is a tool called as Informatica. There is
Yeah.
something called as Ab Initio, and
Yeah.
even I heard from few people that people are using Hive as a data warehouse as well as a ETL tool. I don't know if that is right. So is it possible to do ETL with Hive, and how is Apache Spark better than Hive and the remaining tools?
Yeah. So I'm telling you, so there are different problems altogether. So what does Hive do? Okay, let me tell you a little bit about Hive. Uh, so what happened was, so it's a very expensive job to write a MapReduce job. For example, if you take a developer, right, it will take probably how much you want to pay him. Then from the product, the things will come to the developer, and he will write the MapReduce job, right? And same for PySpark as well. Sorry, Spark as well, right? So it takes a lot of time. The development time is more. So, and there are some companies which really does not need that kind of enriched or transform or aggregated data. They just can do same with SQL as well. And you can do all the window operations in SQL as well. So that's why Hive was introduced. For example, if there is a sales team in your company, and you don't want all your sales guys to either learn MapReduce job or you don't want there will be huge number of developer MapReduce writing MapReduce or Spark jobs and serving your sales team. That's when Hive comes into the picture. It will provide you a query language system which will down in the bottom write MapReduce jobs for you and get you the data, in which the user only have to input the SQL language, right? SQL with window operations and stuff like that. And you can join with the data. And so Hive is a query. Hive is neither a database nor a processing system. It's just a query language, what do you call it, platform. And under that, MapReduce is working. And so you use Spark and Hive in totally different ways. You need Spark when your problem statements are complex, like you have huge volume of data, and the enrichment and transformations you want to do cannot be just joins. If it joins between two tables, you're better off with Hive. Okay. And the main difference will be like Hive is input output extensive. It will be working on Hadoop. It will be getting all the data through mapping and reducing. Whereas in Spark will be memory intensive. It will be getting all that data inside its memory and then will be playing with it. Which is better? Totally depends on the situation. If you are, I mean, your company wants to do, for example, these kind of situations, like you want to do pricing, you want to do recommendation engines. Hive is no match for Spark because it can do that in real time. Whereas in if you just want the sales report, right, on a huge volume of data, go with Hive. There is no point of investing in Spark because it does not make any sense, because if it's not a complex data. Do you get my point, Purushottam?
Thank you so much. Thank you so much.
Yeah, sure. So let's
Abhinav,
come to architecture. Yeah, go
we
ahead.
have one
Somebody
more.
else.
Yeah, we have one more question. Does
Yeah.
Spark has its own resource manager?
Yeah, so it has cluster managers. I mean, that's how it manages all the nodes as well and exports the data to those kind of nodes. It has its own resource manager, but you need to have a resource manager to manage all the Spark jobs. Let me make a little sense. For example, if you have like you want a 5-node Spark cluster, right? And what you will do is basically like you will make one master and then provide these will be my working nodes, these will be the executor memory they will provide to each core, etc. Then what if you want to add more nodes and your processing power, you want to increase your processing power? Then the main resource manager, which will be Yarn, Mesos, or Kubernetes, anybody comes into picture, that they will scale that cluster for you. Okay. And inside Spark, there will be a resource manager which called cluster manager, which will be handling all the working nodes which are present in its directory, or like whatever, like those YAML files, right? That configuration files. So there are two resource managers. One will be handling Spark, and one there inside the Spark, which will handling all your jobs, all your executors, all your everything. We come into that in the architecture. I'll make you explain that better. Okay. Yeah. Getting to the architecture. So how Spark works is Spark has a core. Okay, for example, let's take example of you want to batch process something. Okay, and you have, let's say, 10 GB of data. What you will do is you'll write your Spark code to basically read the data from source, which will be SQL file or whatever. And then you'll tell, okay, do these transformations in which I mean that it will be either like there can be a map, or there can be filters, they can be group wise joins, stuff like that. So those will be the transformations. And how Spark Core does that? Through drivers and workers. So what happens is, your master, whenever you tell Spark that okay, this is my job and this is the task I want to perform, you submit that to the Spark driver. And what does Spark driver do? A very main point, that depends on your problem. It will make a query plan, like just in RDMS, it will make a query plan. It will logically check your code, like is it syntaxly well or not? Is the data uh, is right where we want it to be? So that's where Spark driver comes in. Like it will be scheduling all your jobs. It will be seeing that do you have enough resources for jobs as well? Do you have parallelism in your DAG? So what a DAG is, whenever you provide the code to Spark, it will make a decyclic uh, graph in which it will design the steps in which it has to perform. So it will perform some tasks parallelly and sometimes some tasks sequentially, which is important that it's fault tolerant, because whenever a RDD, whenever a so you need to understand RDD for this, that how actually Spark works. So RDD, if most of you Python guys knows, it can be the list of tuples. So first of all, it cannot be changed, and second, it's a huge number of the data you have collected in kind of list. Okay, so what does it? What will it do? It will ship your RDDs to. So those RDDs will be created as executors, and if those RDDs die, they can be reformed through DAG. So that's the benefit of DAG. And yeah, so that's what I told you about that. What are the main components of Spark Core will be Spark driver, worker nodes, and executors. And Spark driver will be doing all the memory management, job scheduling, distributing the data, and creating the DAG. And DAG, which is very important, which will be probably a flow chart of how the data will be transformed, and what steps can be parallel and what steps needs to be sequential. And once these tasks are defined, then workers and executors come in picture. For example, if we talk about a 5 node Spark cluster, there will be one master in which Spark driver will sit and will do all the orchestrating of all the data. Whereas there will be 4 nodes in which there can be multiple executors. Each executor have one core. So for example, if you have a node in that Spark cluster which has 8 cores, 64 GB of RAM, and some hard disk, some good amount of hard disk, then so the memory can be shared with with one executor, but there can be at most 8 executors on that server. Got it? So those are our executors, and these are called worker nodes. So for example, the diagram given below in the PPT actually has this is shown as a 3 node data cluster, in which one is taken as master, which has driver program. There is where Spark context is made, and in between this sits a cluster manager, which is on master. So it is not another node, but just to show how the data comes in and comes out, we have to show this like this. And there will be these 2 nodes which will be doing all the transformations, actions, aggregations, in which there will be executors, executors will be, I explained to you, are the cores which will be actually performing your task. And yeah, so they have to perform one or more than one tasks, depending on whether your code is sequential or whether your code is parallel. So that's a little bit about architecture. I'm still telling, there's huge depth in this. That's why I think we are running with the masterclass here. And some of the things you should also know about Spark is that it's a lazy evaluated processing. Like, for example, if you take a code, for example, in Python, like you can initiate any variable and then you want to print it. So that initiating can be called as a transformation, like when you are dividing your number by 5, or probably if there is a list, you are filtering out with some data from that list, and then you are printing it, the output. So how Spark works is, if there is no action, no transformation will happen. So that's why it's called lazily evaluated. That depending on your action, it will make the DAG, it will do the transformation, and it will provide you the answer. If there is no action, no transformation is running. The Spark job is empty. There was no processing, nothing. So what are actions? One of them is printing the data, like to your CLI. One of them will be storing the data to some data storage, or one of them will be pushing that data to a queue. You can push that data to a Kafka queue as well. So if one of those things is not happening, Spark will not do anything to your data. No transformations, nothing. I hope everybody is clear with action and transformation, because those are the most key important keywords here. And fault tolerant, I already told you. Like when when Spark takes the data in memory and it initializes into a tuples of list, that is called RDD. And it's called RDD because it's distributed across the worker nodes, and it's resilient, that once, even if your executor is lost, for example, if your worker node goes down or that specific executor goes down, the work which was assigned to that executor can be done by another executor, and that RDD can be recreated because all the data sits in drive.
Sir,
Yeah,
I have a question.
yeah, go ahead.
Can you differentiate between deliver program and worker node?
Yeah, so worker node will be, I told you, for example, if let's take a little bit easy example, that for example, if you have 5 laptops and you have made each of those as a server, and one of them will be master server in which you will be running your Spark jobs. So other 4 will be your worker nodes. Okay. And in that, how many cores you have will be executors. So that will be worker nodes. And what else you want me to differentiate between?
Okay, sir, can I go to previous slide?
Go ahead.
Not this. Can you show that from the starting so that I can see again and I will clear my doubts on the spot?
Okay. I mean, that's the starting. Yeah.
That cloud and that slide one.
Okay.
Yeah, this one.
Yeah.
So in this, if we have to choose one thing, so what is the best from your side?
We can take up this question later, because we were a little deep into architecture.
Okay, if I
thought
will
your
go for the
question was
language.
related to that. Yeah, language, I'm telling you, these questions we can take later. Right now, what you
Okay.
should
Okay.
focus about is how internally Spark works.
Yes.
Cool. Yeah, let's focus on that, and later I can take your questions. I'll tell you which is the best, which is the
Yeah,
easiest,
sir, no
and
problem. We can discuss in the end.
yeah, because that question is not relevant to where we are right now, right? Cool. Yeah, and this will be the good example of how a streaming journey works in Spark, right? So streaming, of course, will be working on real-time data, near real-time data, not real-time, and that data has to be shipped to Spark through some messaging queue, which has to be very fast and taking up that near real time. So each and every uh, prospect you see, whereas in event data system, data stream processing, and data result, all will be distributed, because without that you could not perform near real time data processing, right? So what are events procedures producers, right? uh, Basically, for example, if you are clicking on some movie, or you are spending some time on a hover in YouTube, right? It takes up that data from your clicks or from your hovering over that thumbnail, and push that data to a messaging queue. If it's a data center, it will be Kafka, and if it's something clouded, it can be SQS. We are taking an example of data center for all this. So that data is then pushed to Kafka. Pushing can be happening, will be happening through a web service or an API, right? But now that's data sets in our Kafka queue. And once that data sits in Kafka queue, you can have your Spark streaming job, which will be constantly consuming that data from Kafka and processing and enriching that data, and then providing the data result to a database or another pipeline. So that's how streaming pipeline works. The tremendous thing about this is it can schedule these streaming jobs from like the window can be from 1 to 10 seconds. So in every 10 seconds, it can ask Kafka for data, process that data, and give it back to your data storage. So that's why you see all the Netflix recommendation system. Your Uber driver also works on this principle only, that how this data is pushed. Like you get data from uh, GPS sensors of the driver where he is right now, and that data is pushed to Kafka, and through GraphQL you basically design the cluster in which, like, when I am booking a cab, I can uh, uh, it can literally filter out which are the drivers which are in those area, and uh, then provide you with the best driver you need at that time. So those kind of problems are solved with Spark streaming, and it's the right now it's the only way, except for Apache Storm that also do the same thing. But yeah, I mean, this is the core of each and every stream processing problems you see in the industry right now. So yeah, this will be the same thing. So data from OLTP flows to messaging queues. OLTP will be transaction processing, which will be like happening at real time. Like the transactions happening at Airtel Payments Bank, which I work for, uh, were were actually through Golden Gate. So Golden Gate was the shipper which ships the data from Oracle database to Kafka in real time, and that data was processed in Spark jobs for enrichment of that data, for transformations and aggregation, and then was stored to the data warehouse, which was built on Apache Cassandra at that time. And of course, that data was later served for many reports and dashboards, which we used to work on. Hope everybody is clear with pipelining. I mean, this is where Spark stands out. So if you are anytime interested in Spark, do have a look into streaming and structure streaming, and there is a lot to learn here and a lot of real-time problems you can solve with data processing here. Okay, use cases of Spark. As I was telling you in the journey earlier, right? That recommendation engine is a big time use case of Spark. And if you look at each library of Spark, like there are 4 basic libraries: Spark SQL, Spark Streaming, and Spark MLIB, and Spark GraphQL. They all provide different answers for different use cases. So batch processing is when you need to process complex reports, like you have huge number of Excel and CSV sheets with you build up on like 10s and 20 years of your serving customers. And if you want to run analysis and like probably make reports out of it, then you need to use Spark, because Spark can read any, probably most of the file formats and provide you the data memory and can transform that data to uh, for analysis and stuff like that. Streaming, as I told you, streaming is the main uh, key of Spark here. I mean, it can ingest it can consume the real-time data, and it can enrich that data and saves to for another data models or like data problems like recommendation system, pricing, and what's trending right now. So those kind of use cases, you will be seeing that Apache streaming is the core thing, how they are solving that problem. And Spark MLIB as well. Like, for example, uh, I got this example from net that Toyota uses to prioritize its social media interactions in real time. So UK, there are things like there are APIs for Facebook, there are APIs for Instagram that they will provide you on the basis of price, of course. That how your company is tagged, where is your company is tagged. If somebody is trying to report a bad message to it, then natural language processing will be done on it, and that message will be pushed to you in real time. And after getting that into Spark, you can perform machine learning algorithms to it. You can provide you can do NLP on it, and then you can assign that message to some of your customer representative so that he can solve your problem. So companies right now are very much aware about how people are reacting to them on social media. So that is one problem also solved through Spark. I guess that's the whole I want to brief about Spark. I mean, of course, it's a huge topic. It's not a 1 hour session. Will not justify it, but still, I mean, that's where it will get you started, and it will help you think that which kind of problems you want to solve, and how Spark comes into picture for that processing. I guess Digvijay, over to you. I mean, either we can take questions or you want to.
So maybe I will take just a quick minutes to help you people with the next slides. So if you can have them. So as I was discussing in the beginning, we have a batch on data engineering, which we are starting today. There is a first class also of that. So here, if somebody is interested into in the field of data engineering and thinking of maybe switching their career or upskilling themselves, are existing ETL developers or people like that. So this is a sort of program that is actually built for that. I can give you a brief intro. There's a next slide about the program. So it's a complete 16-week online boot camp that we have designed with multiple professionals, some 8, 9 data engineers, senior data engineers from the industry who are from the companies like Amazon, IBM, Mercedes, Kimberly Clark, etc. So they have come together to create this whole bootcamp. As our thinking is to more of a, not very basic, but like this is a program which is even suitable for people who are currently want to upskill themselves and need that sort of mentorship into their career from some professionals. So we provide, that sort of access to those professionals, as well as all the key technologies which are there for the data engineering is something that we cover upon. As like this current cohort that we have is starting today. So if somebody is interested, we will, we have shared in the chat about they can register, and somebody from our team will contact them. Anyway, so I think we can continue with the questions and everything. If somebody have maybe regarding the program, if you have some questions, you can ask, or if you have questions to Abhinav, you can maybe have a look. So this is a sort of syllabus also, and also if somebody wants to take this as their own learning path, they can follow this. For you to start into data engineering, you have to know a programming language, as this is a more of a software engineering discipline. And on top of it, it's a necessary. You just once you know some programming, you get on with SQL and other NoSQL databases. You take one relational and take one non-relational databases with you, clear your concepts there. Then it's, you go on to the big data platform where you learn about Hadoop and Hive and all those things from very scratch, SDFS, and how the distributed computer programming and all these things are working. Then no, it's advisable that like currently in the industry there are cloud everybody is using. So you take up one of the cloud platform. Like essentially there is not that much of difference. You can take up like AWS. You can, in our course we are focusing on Azure cloud and those things. Then again, the Spark is, I think having Spark in your resume is, it's a must thing right now. If you have it and you have some working experience, have done some project on Spark and all, you definitely are destined to become get a good job at, as a data engineer and so on. So yeah, do check those things out. I really hope this session was helpful for you guys. Now we will just take some questions. So if somebody have, they can unmute themselves and ask directly.
Here is one question. How a student from non-tech background learn data engineering? Is YouTube sufficient to learn, or any specific roadmap to follow, like skills and courses?
Yeah, so you can find every information free on internet. So that's why internet came into picture, right? But still, you need to have a career path. You need to have somebody to guide you. Otherwise, you'll be lost. Because there are so many technologies, so many fundamentals you need to look upon. Taking up a course or getting your mentorship, or looking up on YouTube how to learn that is a way. But I will suggest that at least you get your thing clear, that what do you want to learn and where do you want to go. So data engineering, because has a lot of hats. You need to be good in SQL, you need to be good in coding, you need to be good in architecture, you need to work on cloud, you need to have solutions in your mind that how you're going to project that data. I mean, it's a big spectrum, and I think you should have somebody to guide you in that success, or you should have some milestones to at least work upon. That will be a good idea.
Does Spark follows CAP theorem based property?
CAP theorem, no. So CAP theorem is specifically related to NoSQL databases, right? Consistency, partitioning, and availability. I think that will be not the case with Spark, because all the data will be static, and so all the data will be consistent, all the data will be available because it falls torrent and all the data will be partitioned. So I think it will come into that intersection, but it's not a database, so we cannot call it that. CAB theorem is specifically used when you want to choose which kind of NoSQL database you want to work with, depending on your problem.
Have one doubt.
Yeah.
Spark is only a query processor, right? Then.
No, it's not. I think that's what I explained with streaming, right? It's not just a query processor, because yes, you can work it as a query processor, but it has huge other implementations as well. Because, for example, what you will do if you want to do a recommendation system? We want to build a recommendation system that which movie I should recommend to Abhijit, for example. You need to have real-time data. You need to see what Abhijit clicks on, which genre Abhijit is interested in. And as soon as you are able to recommend that kind of movie, that is the catch here, because all the query languages, for example, query processing can be happen on the data which is already sitting in. And if you are doing processing and then insights and then probably having a API which will taking data from somewhere, this will take huge amount of time. And that's where I guess users log out from that, like whatever the platform you are on.
Okay.
Yes. Anybody else?
सर मेरा एक क्वेश्चन था तो आप
आ जाते हैं, वहीं आ जाते हैं.
Okay.
I think we should stick to English because not
Okay.
not everyone. Yeah, so this is that data engineering spectrum I was talking about. I mean, so your question was which one to choose.
Yes.
I mean, first of all, you cannot choose any one of them. Okay. It will be a huge mistake if you choose one of them. You need to play around in everything. Okay, you need to have, first of all, each one from cloud, one from data, one from language, one from platform, one from visualization. That will
basically
actually,
my question was if I will be choose, so I will be choose wisely, because if you want to learn any kind of thing, so you have to be concentrate and do that course very well. If I will
agreed.
choose Python or Java, so I will choose first of all Java, because if you want to learn coding or some another thing, so you will be concentrate in one thing only. If I will be enroll 2-3 things with Python or Java, so I don't think I will be concentrate doing this kind of
I
code.
agree. So in beginning, you should choose one and concentrate on one. That's right. But you should ask your question that why you want to learn Java. Specifically, if you are in data engineering domain, learning only Java does not mean anything. If you have it, it's a benefit. But most of the things are like, even in Spark. So right now Spark is version 3.8, I guess, 3.x. Let's take it that way. There are no more data frame dataset APIs they are building for Java. They have supported Java till 2.0 version. Now they are not more supporting it. Now
Basically,
what happens?
Sir, I am interested in coding, so that's why I want to learn Java and Python.
Got it, but see, what do you want to code? You want to make websites, you want to make website,
my own website.
No, so I guess probably not even Java is the main like the best language there. I think you should look about Kotlin and stuff like that. They are like huge in the market these days. And yeah, Node.js, why not that?
Because I have an interest to pursue new things. So I'm a basically gain a knowledge. If it is a
So
Java, Python,
are
or
you
other,
are you a student or you are a working professional?
basically I'm doing internship as social worker from Ashpan Foundation. Before I've completed hotel and tourism management,
Okay.
and before that I've complete fashion designing. I will be give my introduction end, so you just finish this. It is so
Okay, cool.
long.
All right. Yeah, then for example, for you, I'll be have one advice. Choose whatever you like. I mean, if you want to learn whatever you like, choose it. Have it. Everything is good if you are, good in learning.
Sir, I think in Java you will go to that is a coding is a lengthy, na? More in line number it will come na? In
Yeah.
Java. Yes. So that's
Yes.
why I think Scala and Python is a preferred for that data engineering.
Correct.
And
Correct answer. One of the correct answers. Yes. First of
Spark is
all, the
also
yeah.
implemented on the Scala. So that
Yeah.
is performance later is also that is good for
Yeah.
Scala.
Actually, Scala has better performance on Spark, better than Python. You were right. Any other questions? I'm not looking at chat. Okay. Cosmos DB is also NoSQL DB. Probably, I've not worked on Cosmos DB. The if you want to know about most prevailing NoSQL DB, will be Elasticsearch, MongoDB, Cassandra, um, DynamoDB if you are in AWS environment. So these are the most prevailing NoSQL databases if you have worked on. Another one is InfluxDB because I've worked on it's a time series database. You should also link about it. And I don't know about Cosmos DB, probably a NoSQL DB. Yeah. Spark SQL versus normal SQL. Spark SQL is it's a library. Um, the SQL is written in the mostly the same way. Some here and there syntactical changes with joins, but yeah, the SQL is same, but the output is totally different. Whereas you will be writing your SQLs on a DBeaver or Oracle developer, just doing on like RDMMS. Spark plays in a very different way. It takes all the thing in memory and can do different things which RDMS can never can. Yeah. Any other question?
Sir, can you go to second slide?
Okay. This, yeah. Or this. So you want to ask questions about me?
Third,
Okay.
sorry.
Yeah. Go ahead.
So wait. What is the Spark use?
Spark use cases. Yeah. I think I told you. Recommendation engine pricing. Those are the use cases of Spark. You can do migration as well. You can provide reports as well. So the more complex use cases in which like industry is using Spark is recommendation engine pricing, shortest distance. Those things are like Gmaps is using streaming for finding your best route to one frame from another at real time. It does on Spark Stream. I mean, it's
Okay.
huge. Yeah.
Okay, so
Anybody else?
Abhinav, I think we need to end the session now. We have one more session.
Okay, cool. Go ahead. I think I am just too much interested in Spark, so I'll keep talking about it.
Yeah, we can talk much time, but we have one more session to join.
Sir,
Cool,
thank you
cool,
so
cool.
much. You clear our doubts very nicely.
Great, Mai. Hope to serve you.
Okay. Thank you, sir.
Sure. Thank you, everybody.
Thank
Yeah,
you.
thanks
Bye-bye.
everyone. Thanks,
Anybody can
Abhinav, for
join me on LinkedIn if they want any kind of career path. I'll provide it.
Sir, you
Thank
can send your link that in the chat box so that we can follow you in the LinkedIn also. I am also in LinkedIn,
All right.
if you don't mind.
I hope so. All right. Bye-bye.
Okay. Yeah, so thanks guys for joining us today, and thanks Abhinav for the time, and it was a weekend and holiday. So still, I hope it was useful for people who have joined. And yeah,
It was a
keep
very nice session. We loved it, and so told each and
yeah,
every slide very nicely.
great. So great guys. We'll close down in a minute or two, and
सर वो जो सर एक्सप्लेन कर रहे थे उनका लिंक्डइन का नाम उनका नाम नहीं
yeah.
पता
So actually,
नाम
if
चैट
you
बॉक्स
have
में भेज दीजिए
if you have registered for the post, so Abhinav was tagged on it, but I am dropping his LinkedIn. I think that
he
should not be a
was saying that
problem.
you can follow also.
Yeah. So I'm dropping his LinkedIn ID. You can test it.
Yes, if it is if it is not a issue, so we can.
No, that's not an issue. Like on LinkedIn, the profile is public. So
Okay.
okay. Actually, I'm not able to message directly. That won't be possible. If you are on the LinkedIn, so his username is Abhinav Workspace. In the LinkedIn URL, so you can contact him, or you can just search AntWak, and where you are registered for the event.
What
in
is
the
the
event,
name?
Name is Abhinav, and it's working in the
Full
NQO.
name.
So on LinkedIn, his name is just Abhinav. It's not a. And on top of it, like you can just from where you have registered for the event, there is LinkedIn ID is mentioned. So you will contact.
I'm seeing.
If you have come down from the LinkedIn post, then the Abhinav is tagged there. His profile is there, right? And if you have come from Luma's page where you have registered, there also in the speaker's introduction, Abhinav's name is mentioned